Welcome to the NPTEL course on seismic design of building structures. Earthquakes in past have caused tremendous loss of lives and property, especially in densely populated urban centers with poorly engineered buildings. Have you ever wondered why some moderate earthquakes inflict disproportionately high loss of lives, or why some buildings perform poorly during earthquakes? As we are aware that India is seismically very active and is currently witnessing rapid infrastructure growth. This makes seismic safety of building structures of paramount importance to our national development. In this course, we will develop an understanding of seismic response of buildings based on past earthquake observations and prior knowledge of structural behavior. The understanding of seismic response of buildings will equip us with scientific rationale behind their seismic design. Upon developing the scientific rationale behind seismic design of buildings, we will learn to design seismic loads on buildings using equivalent static and dynamic methods based on Indian standards IS 1893 Part 1 and Part 5, both 2025 versions. We will discuss how to distribute the design seismic loads across different floors and further among different lateral load resisting members. The estimation and distribution of design seismic force will be illustrated through solved examples. We will further learn how to analyze torsionally irregular buildings using concepts of center of mass, center of resistance, torsional flexibility factor and design eccentricity. The course will then get into seismic design philosophies, where we will emphasize on capacity based design in particular. We will devise hierarchy of failure among various structural members of reinforced concrete buildings, steel buildings and masonry buildings, and learn about their ductile detailing based on Indian standard provisions from IS 456, IS 800, IS 13920, IS 18168 among many others. In case of reinforced concrete buildings, we will learn about ductile detailing of moment resisting frames and shear wall systems. In particular, we will look into their seismic design and ductile detailing of various components such as beams, columns, beam column joints and shear walls using solved examples. Further, we will move to seismic design and ductile detailing of steel buildings, where we will discuss about moment resisting frames, concentrically braced frames and eccentrically braced frames in particular. Ductile detailing of various components such as beams, columns, beam column joints, structural bracage and shear links will be further elaborated using worked out examples. In case of masonry buildings, we will look into ductile detailing of confined masonry buildings and reinforced masonry buildings. We will look into ductile detailing of various components such as walls, confining elements and seismic bands using solved examples. Further, modern buildings have abundance of non-structural components such as critical pipelines, equipment and architectural elements, which need to be safeguarded considering their capital investment. Therefore, upon skilling ourselves into ductile detailing of reinforced concrete, steel and masonry buildings, we will learn about seismic protection of non-structural components of various buildings. Towards the end of the course, we will look into seismic evaluation of existing buildings and seismic protection measures for different buildings. We will get insights about various seismic protection technologies, including base isolation, tune mass dampers and seismic metamaterials. In a nutshell, this course develops a holistic understanding about seismic design. I look forward to you joining the course and learning about seismic design of buildings. Thank you.